All right. So then I'm capturing off of the correct microphone. Yep. Got my display share going. Got my video going. So we're live. All right. So what I'm going to do today is take a demo that another advocate on the team, Amanda, put together, and she's got a great demo that she's put together for the Big Data Day LA conference, and that's tomorrow, by the way. And her talk is about, it's called like Rotten Tomato, when Rotten Tomatoes isn't enough, and she's doing some sentiment analysis of Twitter. She wants to use Twitter to determine if the new movie that's released this weekend is any good. She wants to capture the buzz off of the interwebs to see if it's worthwhile to go to or not. So this is a project that she's got. Let's see. Let's find Amanda on GitHub. There we go. Okay, so this is her Big Data Day LA project, and I'm going to clone that, but funny enough, I've already cloned it, so I don't need to do that again. But, oh, wow, should I do that? I turn once to update. Why not? Let's see how fast it goes. Is it going to remember my sessions is the question. See, I always have this risk of, it sounds a lot like doing an OS upgrade right before demo. So basically what we got here is a set of instructions, and I like to make, I gave Amanda a little bit of a hard time because there's a lot of setup instructions here, and kind of takes a while to get this demo going. So, you know, API access to Twitter, I know she's making that a little bit easier, providing some CSV output so you don't have to get an API key, which makes things easier. So that's cool. She gave me her API key because it's one per organization, is what it says. So I guess fair enough. We are in an organization. So this next step here is install DataStax Enterprise, start your analytics cluster, Cassandra, with the -K option. This is the analytics mode. Then you need to set some environment variables for your API keys. And then this is a bunch of Python-related stuff that you need. You know, so you need, this runs off of Python 2.7. I'm not going to do, well, okay, I am going to do it, my typical rant about Python. I mean, I really like Python, but why are there two versions? Let's get it together, people. 2 versus 3. I'll probably get down to 3. Come on, worldwide software development community. So DSE Analytics will be there. We're going to use Jupyter, and there's some customization of the path. This is a workaround, and actually, I believe this bug has already been fixed and should be in the next release of DSE. However, we're running Jupyter, and then we also, by the way, there's also some Python packages that we need via pip install. And then there's a PySpark. Because, don't install PySpark because it actually already exists. So the setup here that Amanda's describing is basically, I'm going to get like a virtual machine, right, running Ubuntu or something like that, Linux, most likely. And then I'm going to install DataStax Enterprise on it. It might be a tarball install. A lot of people do that. And then, you know, do some Python package installs, and including Jupyter and some of these other dependencies, which is a fairly typical set of libraries for a data science type project. And then we're going to get good to go. I'm lazy, and I just have this aversion, I guess, of working with VMs. And so I was like, I've been into Docker lately. We've done all our killer video stuff on Docker, so okay, let's Dockerize this thing. So what I'm going to show you is the process I went through to Dockerize this application. So let's see. DataStax Docker images is my history here. The DataStax releases these Docker images. We have them for Op Center and Studio. It's our operational tool in our developer environment, but what I really want is the server. So we can actually see those on Hub. So the one I want is BSD server. So actually, I already have this pulled locally. Let's see what I can do here. So Docker images. I have a few versions actually installed, but this XBSD server. So latest is 6.0.2. It's going to be the one I want to use. And like I mentioned, I already cloned the repo, so I'm going to go to LA, my clone repo. So I've got some stuff in here. I've already been working on adding some things to this repo. I got some local files. So for example, let's see, I've modified the notebook that Amanda started with, and then I've added some things which I will talk through with you here. Let's see. I'm going to probably blow away that one directory, but let's see where to start. Let's see, there is a. No, I know. Okay. So we're going to look at Docker Compose. So I'm using Docker Compose, and my goal is here. Just to back up for a second, my goal is here to get two separate containers running. One of them is going to have Jupyter running in it, and the other is going to have my DSC server. The reason I'm doing that is it's all fine and well to when you're running in a VM, like install DSC in the VM and then install Jupyter on top of that and crank both of those things up. The Docker ideal deployment model is really one process per container, right? So therefore, that would do things in quote-unquote right way. I'm going to have a separate container, one for Jupyter and one for DSC. So when you go on the YAML here, you can see some of the things that I've had to do to get this set up correctly. So first of all, I'm starting DSC. I'm using the latest image, DSC Server 6.0.2. I'm using the -K option, which is what Amanda said to do, to start my node in analytics mode. And yes, I'm just running a single node cluster here. So this is not meant to be any sort of realistic operational scenario. It's not. It's development. That's what Docker does really, really well, especially for distributed databases. And of course, we use it. Lots of people are using it in production too, but it's really, really good for me for development on my desktop right now. So I'm going to expose on my DSC image. I'm going to expose the Cassandra port 9042, and I'm also going to expose this DSC FS. So this is the DataStax equivalent to the HDFS to the file system. So there's no additional port that's actually required here for Spark for the analytics piece. It's actually all this traffic is funneled through that port 9042, which is the Cassandra port. This is done via CQL. Environment. Just in order to use this DSC server image, I need to use the DSC license accept. This is my way of acknowledging that, yep, I understand that the license terms of the DataStax provided Docker image, and that it's, among other things, that it's not approved for production use. So, and then there's a couple of things that we do best practice to use with this, because we're running a database in a container here, IPC lock and memlock settings. You can find kind of the explanation of that here on these pages, but on the GitHub stuff. You can also get to the documentation through the DataStax website. Where did I put that one? Huh. Oh, here it is. My bad. So DataStax documentation landing page for Docker. Good. Okay. So back to our YAML file. What we have here in the YAML file is the second thing, and more interestingly, I've created a custom image here, and I may go the route of actually putting this into its own GitHub repo under my GitHub. Right now, I'm just kind of building it locally in a subdirectory, and I'm just calling this thing Big Data Day LA DSE Jupyter. That's because it's an image that has DSE and Jupyter in it. And you say, wait a minute, what? Didn't you just say you had separate containers? Well, what I'm doing is I'm actually running Jupyter in a modified version of the DataStax Enterprise server container or image. And the reason that I'm doing that is because I want to be able to kick off Jupyter in the context of a DSE node, because it has a mechanism called DSE exec for starting other processes with all of the DataStax goodness, all the DataStax Enterprise and open source libraries that you would need on your class path. And so this is actually something that is sort of hinted at here in Amanda's instructions. So start Jupyter with DSE to get all the environment variables, right? And I would say libraries. DSE exec Jupyter notebook. So that's the command that we'd actually like to be able to execute to kick off Jupyter. Okay, so for that reason, I'm actually starting Jupyter. I built up this separate Docker image with Jupyter on top of DSE. The port is 8888 that the Jupyter notebook server will be exposing, so I'll end up hitting localhost 8888 to actually get to the Jupyter notebooks when we get this thing up and running. Let's see. So one of the cool things is I've actually got this, there's this notebooks directory under the current repo, which is where Amanda has put the Big Data Day LA demo notebook. And I am going to mount that to a new directory inside this DSE image that I'm playing with called Guarded Jupyter. And I'm going to set that as the home directory for Jupyter when it starts up. Okay, so again, accepting the license. And notice here that I've actually got all of my consumer keys here, my API keys set up. I'm going to pass them in as environment variables when I start the image, and then also link to link here to DSE so that Jupyter can talk to DSE. So just to show you real quick, I'm going to get another new tab. Okay, so there is a here, how do I do this? I've got an env file here, and I'll just do this so that you can not see my actual keys, but you can see that these are the keys that are using, and I've done a compose name in a compose file. So I can get to that stuff. Okay, not sharing my keys with you. This is the Docker compose that we'll use to kick off everything. So we'll get out of that guy. So how did I build up this image? I'll give you a quick tour without all the gory details. I'm going to look at this. Created a separate directory for this DSE Jupyter, and there's a Docker file. So this is based on the latest DSE server image. Notice I'm as root. I need to be able to be root so that I can do an apt-get update and an apt-get install with a -y. I learned that the hard way. -y means answer yes to every prompt. Otherwise, the Docker file will error out because it wants a response. The install script, the apt-get command wants a response from you, and it's not going to ever get one. So it errors out. So that's why I mean accepted all the defaults for everything basically. So I'm going to install Python. Sorry, Python pip, the package manager for Python. Then from there, I can install Jupyter and the Cassandra driver. And actually, I was talking to Cedric, and I will probably other developer advocate on the team. If we want to start doing anything more advanced, involving like graph frames, for example, do graph analytics problems, we're going to need the DSD driver at some point. Now, for now, the Cassandra driver is okay. And then Tweety pattern, pandas, these are the additional packages that Amanda is using in her notebook. So I need to make sure those are installed. And then I don't have to do any, I figured out my Python packages installed. I can jump out of being root back to the default user for the DataStax enterprise image, which is DSE. And I'm just declaring this var lib Jupyter directory as a volume so that I can mount that external notebook into it. And I'm going to expose 8888, so for the Python, for the Jupyter notebook. And then I'm going to define a new entry point. So this, the DSE server image is set up to start DSE, obviously. I'm going to override the entry point to make it do as Amanda's instructions hinted or suggested. It's going to run DSE exec Jupyter notebook. And then there's a couple of things that I had to do to get this running, like within Docker to get the networking to work correctly. I tried a few different options, ended up with this set IP to 0000. Again, I'm not fantastic with the Docker networking, so don't know if this is the best, but it's also going to run on port 8888, which might actually be the default, but I went ahead to be explicit. And then notice here that I started it with that notebook directory. It's pointed at that var lib Jupyter. So when I run this container, I'm going to mount something onto var lib Jupyter, and then that's where my notebooks are going to be. So my notebook is actually just running on my file. It just exists on my local file system, and it's mounted into the container at runtime. Okay, so boom, that is how I built that image up. So next thing is, let's see, looks like it's running today. Docker compose up -d runs in background. My log files come wherever. You know, I don't know why I got into the habit of using Kitematic to view the logs, but you can, when you're running Docker, you can start Kitematic. I end up using, the only thing I don't like about it is you have to like refresh the view sometimes. It doesn't seem to automatically update everything, but it is a lot handier than writing tail commands all the time. So this is the reason why I like it. So I'm going to refresh this guy. Let's see. Was it already up? Oh, look at this. Okay, my demo was actually already up. I left it running from before. It's bad hygiene, I guess. And I guess that means that I can actually, I'm already logged into this notebook. Every time I start a new instance of Jupyter, it brings up a little screen. I don't know if you can see it here, but it looks like it asks for a token. I didn't go in and go through the process of setting up a different login yet, like overriding the default token to set a password in the Jupyter notebook. I'm just taking whatever it is. So whatever the token is by default. So the way this works is you start up you do your document compose, get everything started. You go in here to Jupyter in the Kitematic, so see my Jupyter image, and then it's going to give me a token. And here it is. So you see that token there, I copy that, and then I can click this to open up the page in the browser. It's not going to ask me for it because I'm already logged in, but I could easily, if it did want me to, or if I logged out, I could just put that token into the login screen, and then I'm logged in. Here I got my notebook cranked up. So open this guy. So I'm just going to run through this. My purpose is not necessarily to give an explanation of Amanda's demo, because it's her demo and she does it way better. So I'm just going to click through some of the stuff here. this is this little workaround to make sure that when you run Jupyter using DSE exec, it puts all the goodness on the class path that you need, except for these two little things here, PySpark and PyPyJ. And that, like I said, this is a workaround that'll be fixed soon. All right, so we're going to do some imports here, get all the libraries that we need. Again, there's something that I don't understand about the warning messages that it gives me, and in fact, it didn't give them to me this time, so I guess I won't worry about that. So she's defining some helper functions here, and then, okay, fun stuff, connecting to the Cassandra cluster. So she in her notebook actually had this connected DSE. And actually, I might be able to show this, like, get this. So, I'm going to go into the notebooks directory. I think it'll show me this. So there's some stuff. Oh yeah, she's already changed this on her new image, or on her repo. I haven't. Obviously, Amanda's been working on her demo, and I haven't pulled her latest changes. But as of recently, she had a custom path set to these DSE libraries. I changed it to what it looks like in the image, which is that it's under op DSE resources. So let's see, there's another. Oh, that's just an error message. Well, this may or may not be interesting. Get to the interesting parts. Oh, here it is. Okay, so see in hers, she's connecting to 127.0.0.1. So because she has Jupyter and DSE running on the same server, she's got it pointed to localhost. I have it where this is running in a separate container, and to use the Docker terminology, remember that DSE server image, I gave it a name of DSE. So this DSE will resolve to whatever the IP address is of the DSE server in the Docker network. Make sense? Good. Okay, so I'm connecting. So now I'm connected to the Cassandra DataStax Enterprise cluster via that, using the server DSE as kind of my entry point. Okay, and then if not exists, so I can run this as many times. I've already done this before, but there's no harm because it's got an if not exists on it. So it turns out DSE Analytics demo as a key space already exists. Awesome. So I'm going to use that key space. And then for her demo, we're doing sentiment analysis on Twitter, on tweets that reference the movie Mission Impossible. And we're going to define some variables here. We're going to look for both positive and negative, and then we're going to create a table to store the positive. So movie tweets 2, Mission Impossible positive, movie tweets 2, Mission Impossible bad. Two different tables to store the results basically of two different calls to the Twitter API. So set up our search terms. We're going to we're going to find some helper functions here that are going to clean up the tweets after we pull them from Twitter to remove some emojis and punctuation and other special characters. And then look, we're actually setting up our environment variables. So those were passed through. They were set in that .env file on my hard drive, and then those got passed through by means of starting things via the Docker compose with environment variables got passed through here. And so then we're going to pull all the tweets. We're actually have a page size of 100 maximum that we're kind of rate limited to by the Twitter API. So then it's going to iterate through these. Well, it's going to make a couple of API calls to get those, and then it's actually going to insert. Oh, I'm sorry, it's already inserted those into the Cassandra tables, the positive and negative tweets by this point, and then we're actually just going to, this stuff just, I think it's just showing us the results of what we got and put into Cassandra. Okay, so now we're actually at the point of the demo. We're going to do the analysis, and let's see here. So run this query. Now this is actually the part of this effort that took me the longest to figure out. And this is all in terms of DSE as the name of the machine. So we need to tell Spark, we're basically creating a Spark session, and because it's connecting to DataStax Enterprise that is not on localhost, there's several of these configuration parameters that we need to set. One of them is to say where the Spark master is. So that's using this DSE protocol, and the host name is DSE port 9042. We also need to tell it where Cassandra is, that happens to be on the same host, DSE. We also need to tell it where Hadoop is, also DSE. Or we also need to tell Hadoop where Cassandra is, I guess, which again is that DSE host. And then we also need to tell the Hadoop file system, which is actually the DSE file system, where that location is. And then this is for our Spark client. It needs to know the location of all these things, and they're actually all be pointed at this one DSE server. My final step that I'm going to work on actually after I go out there is moving these config settings to a config file so that they don't have to be inside this notebook. And that's going to actually help me make a more general purpose image for Jupyter. Okay, so then I won't attempt to explain the details of the queries, the Spark jobs that are being run here. We'll save that for Amanda's demo. So she's got the tweets, she's pulling them, she's analyzing them, she's tokenizing them, she's doing sentiment analysis on the various words that are contained in the tweets to determine whether each tweet is a positive or a negative tweet. Stop words removed, and then she's using the pattern Python package to do these final steps here. Right, and the net result of this demo is, should I see this movie? There's more positive rating than there is negative rating, so there's more positive feedback than negative feedback in terms of weighting of the sentiment in these tweets. So we're going to conclude that by and large people like this movie. So that's a total run through the demo. It's all Dockerized now. So one of the tricky last steps that I need to get to here is actually overwriting the configuration file. There's no, if I look up here at these three attributes that I need to set, I went through and there's actually no specific config file in the DSD distribution that contains these. But what I did is I went through and I did some rep commands to see what files, which config files were most likely to have things like Spark Cassandra and Spark Hadoop, etc. connections in them. And let's see, I think I figured out that. This is my DSE node. I switched over to look at its log. I'll just get a command prompt over here. All right, so I'm in, it puts me in off DSE, so I'm going to go into the resources, no tab completion. Just remembering my way around here. Spark. So I think it's in here. So then off DSE resources Spark const, and then there's this. Where's it default? Spark defaults.conf. So, oh, there's no VI either. Spark D. Old habits die hard, man. In this file, I can actually just put. I'm going to make my own version of these, of this file. Basically, probably just like append the attributes, the config values that I want to set. And put it into that. Now, the way that I actually get my modified config file into the image is through a feature that our DSE images support called overwritable configuration files. I wonder if I could do a decent job of explaining that on the fly. I didn't really rehearse this part, but DataStax Docker images, if I go in here and read about, not Studio, that quick. Docker images, I go into server, and then 6.0, and files directory, I'm going to go, here's this thing, overridable configuration files. This is a list of files that if I provide like a JVM options file, and I put it on my local drive, then I actually can overwrite the contents of any of the config files listed here. If I stick them in a directory on my hard drive and then mount them to a config directory inside the image, then DSC, when it starts up, will look at the config directory, this is basically off of root, mount it into the config directory off of root, and then copy the config file that I provide into the right place. And sure enough, this, where is it? Defaults. There it is. Spark defaults. It does exist as one of the overwritable configuration files. So this is my next step I'm going to do later on, is I'm going to make my own copy of Spark default, and copy the one out of the image, and then I'm going to add in the config properties that I want, that I was defining in my notebook. These guys that I was defining in my notebook, I'm going to define them in my overwritten version of sparkdefaults.conf, and then I'm going to swap them in. And that's actually the last piece here that I didn't talk about in, remember that that Docker file that I was showing you. Oh, not that, the Docker compose. Sorry. Remember this thing. Okay, there's the local config directory in my repo here, my little copy of the repo here, config directory is going to mount to /config. And then what that's going to have in it is the contents of this config directory, which is empty right now. Except for a core site XML, because I thought I was going to make a core site XML, and that was going to be the right place to override the properties, but I actually think that it's going to be this Spark default file. Okay, so that was everything that's involved in setting this up. I mean, I'm going to go through the process of seeing if I can turn this image that I've just built here locally into a more general purpose image for building off of the DataStax server image to install Jupyter and run Jupyter on top of it. And then hopefully we can create a bunch of demos that a bunch of demo notebooks, and then just run them super easy in Docker on top of DSC, just saving you a bunch of install steps. So that is the plan, and that's the demo, and that's, I think, all I'm going to talk about today. There we go.